Hi everyone. In this video, I'm going to explain about topological sorting. Already we discussed many sorting techniques. So like bubble sorting, selection sort, insertion sort, merge sort, quick sort. So then we discussed about distribution counting sorting, then comparison counting. Then other than that, we have radix sorting, heap sort. So like that, all these different sorting techniques are used to sort the numbers. Given some set of numbers, that's numbers we are rearranging in some either ascending order or descending order. Okay, that sorting algorithms we discussed. But now this is the sorting technique, so which is used to not to sort the what numbers, but it is used to sort the nodes of the graph. That means given some graph, that in the graph we know that what the graph definition. What is the graph definition? The graph is designed as what? Set of vertices and edges. That means it contains some number of vertices, also called as nodes. Now we need to visit all those nodes in a systematic order, in some systematic manner, one after the another, in a linear order. We need to visit all the vertices. So that linear ordering of the nodes is done by this topological sorting. So in simple words, topological sorting is used to find the linear ordering of the nodes of the graph. That's for the topological sortings. Now we know topological sorting, what topological sorting. So now for what type of graph we can apply this topological sorting? This topological sorting can be applied to the graph, and that graph should be directed acyclic graph. Now let us see what we mean by this directed acyclic graph. Let us take simple example. One vertex A to B to C, D. There are four vertices are there. Assume now it is having, this is my graph, this is one graph. Here all the edges are not having directions. So all the edges should be have some directions. For example, let us take this is and this directions. Okay. Now all the edges are having some direction. So I will call this graph as a directed graph. Okay, so the graph should be directed. Okay, so here D stands for what? Directed. That is done. Next, A stands for acyclic. Acyclic means our graph should not contain cycle. Whether this graph contain any cycle here, yes, cycle is there. If you observe here, see, it is going like this. It is coming from here and then it is going like this. Some closed path is there. Just keep running here only. So it goes here, comes here, again goes here, like a closed path is there, closed loop is there. That we call a cycle. Like that cycle should not be there. So if the graph is having cycle, to that we cannot apply what? This topological sorting. So in order to apply topological sorting, the graph should be what? Directed, and it should be acyclic. Acyclic means it should not contain any cycle. So this is what that directed acyclic graph. So in order to apply our topological sorting, our graph should be what? Directed acyclic graph. So now I'll write the same graph. Now I'll write, since this contains some cycle, now I will make this is one direction. Let us take this is also like this direction. Now we'll change this as in this direction. Now this is again graph. Direct, all the edges are direction, so directed graph, but there is no cycle here. See, I'm coming here and I'm coming here, but I'm not going there. Again coming. There is no cycle, there is no closed path. So for this kind of graph only we can apply what? Topological sorting. So now we know what do you mean by topological sorting, for what purpose we are using topological sorting, and for what type of graphs we can apply topological sorting. Okay. So first, in order to apply topological sorting, we need to check whether the given graph is directed acyclic or not. If it is directed acyclic like this, we can apply. Otherwise, if it is acyclic, we cannot apply. Okay. This we hope if people understood up to here. Let us take one simple example. Assume a student has to get a degree certificate. Now the condition is, in order to get the degree certificate, the student has to complete 5 courses. Okay, 5 courses. The course 1, course 2, course 3, course 4 and course 5. So if the student assume, for example, if the student complete all these 5 courses, then only he will be able to get the degree certificate. Now, but in what order the student has to take the courses? Can it take any courses in any order? No. So now first, see course 1 and course 2. Okay, this is the things. So course 1 and course 2 has no prerequisites. It means course 1 and course 2, no condition. That means the student can take any course arbitrarily first. Either taking course 1 first, or he can take course 2 first and then course 1, or course 1 first then course 2. In any order he can take. But in order to take C3, course 3 has to be taken, course 3 after C1 and C2. That means course 3 has to taken after completing course 1 and course 2. If the student has completed both the course, then only he can take the course 3. So next, similarly, so student can take course 4 only after completing course 3. Similarly, student can take course 5 only after course 3 and course 4. Then only can take. This is the prerequisites. Okay. Now this scenario, now I am going to represent in the form of graph. Now course 1 and write course 2, I am writing course 2. Now either the student can take course 1 first or course, but after completing 2, then only can take what? Course 3. That means after completing C1 and C2. So I am writing like this. Then after course completion of 3, then only he can take what? Course 4. Course 4 can be taken after course 3. Course 3, C4. Okay. Next, when the student can take course 5 after completing course 3 and as well as course 4. After completing these two, then course 5. So same example now I represented in the form of the graph. Now we will apply topological sorting to this one. Now topological sorting can be applied by using 2 methods. Okay. The first method is source removal method. Source removal method. This is also called as Kahn's algorithm. Okay. Second method is DFS method. DFS method. Now, we will discuss first source removal method. As the name indicates, source removal method, what we will do for in the given directed acyclic, see here it's also an acyclic graph, there is no cycle, all the edges are in cycle. Now here what we need to do, first identify the node which is having 0 in degree. 0 in degree means there are no incoming edges. Now for example, look into this graph. Now this is having how many incoming edges? See 1, 2. This is having 2 incoming edges. Similarly, it is having how many incoming edges? Only 1 incoming edge. This is having how many incoming edge? It is having 2 incoming edges. This is having these 2, no incoming edge. So we will call this as a source node. That means the first, now we are discussing what? Now I am discussing what? Source removal method. In the source removal method, I need to identify the source node. First identify the what? First step, identify the source node. Which is source node? Node which is having 0 in degree, that is called the source node. Now in this example, which are the source nodes? C1 or C2 you can take. Here 2 possibilities are there. You can take anything arbitrarily. Okay. Now that you need to remove now. Now I have to remove. Now let us assume I have taken course 1 first. Now this is the given graph. From this given graph, now I have removed what? Which one? Identified. Which are the source node which is having 0 in degree, C1 and C2. Which one I can take? Either I can take C1 or C2. Now suppose if I select C1, if I remove C1 from this, graph, now what I left with? I left with what? C4, C5, C3. So this is as it is. C2 as it is. C1 I removed. When I remove C1, it's associated outgoing edges. That also I removed. So this is my resultant graph. Now which is the first one removed? C1. Next. Now again in this graph, identify which is the source node. That means identify the source node is which one? A node which is having 0 in degree. it is having 1 in degree, it is having 2 in degree, it is having 1 degree, it is not having any of the degree in degree. So now I'll remove this one. Now if I remove from this node, if I remove which one? C2. If I remove C2 node, then what I will get? My resultant graph is C4, C5, C3. Okay. Now this is my resultant. Now here again identify what? Again when I remove the C2, its outgoing edge also I remove this one. So this is the resultant. Now again here what? Identify source node, remove this. Again here which is a source node? See, it is on 1 in degree, it is on 2 in degrees. So now which is source node? It is not having any of the incoming, it just doesn't have. So now I will remove from here what? Now I will remove C3. I will node C3 is the source node. So I will remove this. If I remove what I will get? C4, C5. Now this is, when I removing C3, its corresponding outgoing edges also I removed. Now I left with only C4 and C5. Now again from here, now here again identify source node. Which is source node? It is one incoming edge. It is not having any of the incoming edge. So this is my source node now. Now from here, if I remove what? C4 node, what I will get? C5. Now this is the only node I left. Again, it is also not having any of the in degree. That means incoming edges. Now you remove this one. So now what order I removed? I removed first one what? C1. C1 I removed first. Then I removed what? C2 I removed. Then I removed what? C3. Then I removed what? C4. Then I left with one. This also I removed. Okay, then that means this is my order. That means I visited the nodes of the graph in this order. This is what topological sorting, linear ordering by applying source removal method. Now you can say, instead of starting C1, I can start with C2. Yes, you can start that also for that again. Okay, now for the same thing, now instead of removing C1, here because in the given this graph, both C1 and C2 both are having 0 in degree. That means 0 number of incoming edge. So somebody says C1, if you start C1, this is the order. If somebody will start from C2, yes, if I start removing from C2, now what is my resultant graph? Resultant graph is C4, C5, C3, then C1. This is my resultant graph. Now again, from here again identify the source node. Now which is the node with not having any incoming edges? See, it is having 1, it is having 2, it is having 1. This is having 0. So if I remove now C1, now my resultant graph will be C3, C4, C5. Now again identify your source node. Here again this is having 1, this is having 2 incoming edges, this is having 0. So if I remove C3, then my resultant will be this one, C4. Now again here it is having no incoming edges. Suppose now if from here if I remove what? C4. If I remove C4, so then I got what? Only C5 left. Again this is not having any incoming. So if I go in this order, which is the first one I removed? C2. Then I removed what? C1. Then I removed C3. Then I removed C4. Then I removed last 6, 5. That means for this problem, there are 2 solutions. Okay. So if you start from C1, this is the linear ordering of the nodes. This is the linear ordering if you start from C2. This is by source removal method. It is also called as Kahn's algorithm. So hope you people understood. Okay. So in order to implement this source removal method, data structure is just Q. Okay. So now we will discuss now DFS method. Now how to visit the nodes of the graphs in a linear order using topological sorting by using DFS method. DFS stands for depth first search. Okay, depth first search. This is another algorithm. Okay, this is again graph traverselling algorithm. Okay, that we'll discuss in one more video later. Okay, so now it is uses this method. According to this method, now we are maintaining one array called unvisited array. Okay, unvisited. That means our intention is what? Our intention is to visit all the nodes of the graph. So which are the nodes are there? course 1, course 2, course 3, course 4, course 5. What I will do, initially I will say all these nodes are unvisited, so I am making 0, 0, 0, 0. Indicates unvisited. Whenever I will visit the node, I will make it 1. So when I will make it 1, so now for this to implement this, so we are using stack. Okay, I am using stack. On stack. Okay. You know, people know stack. So whenever I am making an unvisited vertex, I push into the stack. I push into the stack. Okay. Whenever I will reach the dead end, whenever we are visiting the unvisited vertex for the first time, I am push into the stack, and I will note the order in which I am pushing. Whenever I will reach the dead end, I will taking out. Okay. Dead end means from any one vertex, I cannot move to any other vertex. Then that is called a dead end node. Okay. Now let us travel through this one. Now, here, from which vertex I can start? So here I started either from CR, C1 or C2. Let us take a start with C1 only. Okay, now course 1. Now this is the course 1, initially unvisited. Now what I have to do, when unvisited, I am visiting the first time, I am push this vertex into the stack. So that means now we will say course 1. This course 1 is the first one I am pushing into the stack. So course 1, first one I pushed, just for a mark. I pushed into that. Next, from course 1, I can move to which and all the nodes. There is no other option. From course 1, I have to move to what? Course 3 only. There is no other option. So from course 1, I am moving only to the course 3. So again, course 3 also unvisited, 0. So again, I am pushing that also into my stack. Course 3, and this is the second one I am pushing. So course 3, 2. The second one I pushed. Next, from course 3, now I have two options. Either I can go to C4 or I can go to C5. Which one I can take? Let us take one in order. Okay, you can visit 4 also or 5 also. But now from course 3, I will move to course 4. So if I move to course 4 is again what? Unvisited. So what I will do? So I will go to course 4, I will push the course 4. Course 4, and this is the third one I pushed. This is the first one I pushed, the second one pushed, third one is pushed. Okay. So now course 4. Now right now I'm in course 4 now. Now from course 4 I can go to which other node? No option. I have to go to what? Course 5 only. So again course 5 is what? Unvisited. So again I'm pushing into the stack. So course 5, and this is the fourth one I pushed. This is the 9. Now right now I'm in course 5, and from course 5 I cannot go to any other nodes. Now that means this is the dead end node. Whenever we reach the dead end node, what I will do? I will pop. Now which is at the top of the stack? This is at the top of the stack. Now if I pop out, okay, if I pop out which one? Course 5 I popped out, and this is the fourth one I pushed, and this is the first one I popped out. This is the first one I'm taking out, course 5. Since course 5 is popping out, that means I visited that. Now I'm making this as a 1. That means course 5 is visited now. Now once I take out course 5, now what is left in my stack? Left in my course 1, this is the first one I pushed. Course 3, this is the second one I pushed. Then course 4, this is the third one I pushed. Right now this is at the top of the stack. So now which is the top of the stack? Course 4. That means I remove this one. Now I am in the course 4. Now from course 4, I can visit only to this option, but this is already removed. And this is a removed. Okay. Now course 4, there is no other adjacent vertex. I cannot go to any other vertex. So again, course 4 is what? Dead end node. Course 4 is dead end node. That means now again I have to pop it out. That means course 4 I am popping out. Course 4 is the third one I have pushed, and this is the second one I am popping out. Okay. Now if I pop this course 4, since I am popping, I am making course 4 as visited 1. So now what is left out in my stack? Course 1, this is the first one I pushed. Then course 3, this is the second one I pushed. Now course 3 is at the top. Now right now I'm course 3. Course 3 I can visit where and all? Course 4 and course 5. But both are already visited. That means I cannot, suppose some other nodes are that I have to push. But here in this example, there is no other node. So I cannot go to any other node. So that means C3 also is a dead end node. So again you pop out what? Course 3. That is course 3. which is second one I pushed, but third one I'm popping out. So since I'm popping this, I'm making this also visited. Now, right now, what is the result of this one? My stack is having only one node, that is the course 1. Now, right now in the course 1. Now, course 1 I can go to C3. That's the only option. But course 3 is already visited. That means it is also what? Dead end node. So, dead end. So, now I am popping out this one also. This is which one? Fourth one I popped out. First one, this is the popped out. Second one, this is third one is fourth. This is the fourth one I popped out. Okay. That means C1 is the first one I pushed. Fourth one I am popping out. So, if I popped out, now my stack is what? Empty. Stack is not empty now. Now, since course 1 as I popped out, this also visited. Now, which is unvisited now? Check in this array, only course 2 is unvisited. Now, that I pushed into that one. I pushed course 2 I pushed. This is which one? First I pushed this one. Second, third, fourth. This is the fifth one I am pushing. But again, course 2 is already dead end because from course 2 you cannot go to either one because course 2 I can go only to course 3, but course 3 is already visited, no need to visit again. Okay, so course 2 is dead end. So if I remove course 2, okay, this is the fifth one I pushed it and this is the fifth one I popped out. Now my stack becomes empty. After this now, since course 2 is taken out, popped out, this I'm making one. So one stack becomes empty, check whether this all the vertices are visited. Yes, all are visited. So now just make a note in which order we have put, which order we have popped out. C5 is the first one. Then I took C4. Then I popped out C3. Then I popped out C1. Then I popped out C2. Now you reverse this. Now this is the order I taken out. But now you have to reverse this one. If I reverse this, I get C2, C1, C3, C4, C5. This is my result. This is my linear ordering of my vertices. Okay. Same thing. If you check, see, both are same. This is by source removal method I got. This is by DFS method. Okay. Now here if I start with C1, if you start with C2, you will get this answer. Okay. Hope you people understood the concept of this topological sorting, both using both source removal method and as well as DFS method. Okay. Thank you. Thanks for watching. If you have any questions or any doubt, please write it in the comments. Thanks for watching.